everyone. Welcome to today's RIEGL webinar. Today's topic is going to be on registration workflow, particularly with using AR2 and MSA2. I'll explain what AR2 is and MSA2 is getting into the presentation, but I'll introduce myself a little bit. My name is Nguyen. I'm the Business Development Manager, specialized in TLS products, TLS scanning, terrestrial laser scanning, and RIEGL California lead. So if you guys don't already know, recently at the beginning of the year, we announced our new presence in California, Long Beach particularly. So I'm able to take in control of that. Let's get started. We'll save some questions towards the end. If you have any questions, please just send them in the chat. And I think I have until 2 o'clock, and there's another webinar coming on. So take a look at the agenda. It's pretty short, but there's a lot of stuff in there. So RIEGL TLS automatic registration workflow. So we're not going to get into the weeds with Joseph's Manager. That'll be for another webinar because Joseph's Manager is pretty big. But I will show you what's required in Joseph's Manager in order to get you to reference your project into your coordinate system that you're working in, whether it's state plane, UTM, or just WGS84. And then we're going to take a look at automatic registration 2. We're going to go through the workflow and then the motion session adjustment 2. Now, I just wanted to let everybody know that this workflow is supposed to be simple, and it's supposed to be quick, and it's supposed to be fast, and it's supposed to be robust, right? And we're trying to minimize that by reducing the amount of clicks that's required. So we're trying to really streamline this workflow. But it really also starts out in the field too as well. So we're going to look at some recommendations that will make your acquisition successful. And you should take these into consideration, right? Because in order for all this to work well, we need the scanning to go well, right? So generally it's best to place the scan positions one after another in a consecutive fashion. So what I mean by that is that you want to just start and just go to the next one going forward. You don't want to jump back and forth if avoided. Now, these are just all recommendations. Certainly, you can move around in a little bit more dynamic fashion rather than just going one position right in front of the other. And it's also recommended, but not mandatory, to have survey control, at least first and last scan of each project, right, of the project. So if you're going to incorporate survey control, now we're not saying that this is the best practice, but we are saying that this is the most, the fastest way to tie your project down to survey control. Now, in the past, the bread and butter way is to resection every single scan position, and you certainly still can. And you can even do that with the new scanner that's out, the VC400i, the latest scanner that's out, by fine scanning the targets right on board of the scanner itself. Now, in the past, to really be successful at resection everything, every single scan position, you have to use a RISCAN Pro, which is ran through a laptop, right? So you got to have a laptop out in the field, and then you also got to have the RISCAN Pro, and then you got to have the scanner. So you have a lot of stuff in your hands. By reducing the amount of control necessary and needed for this new workflow, and then also having the fine scan function on the scanner, we can then eliminate the use of a laptop, the use of RISCAN Pro. So it is recommended to start out your first scan position on 2 survey control, and then your last scan position on 2 survey control, and then some survey control in between. Now, we have some numbers and some values here that we'll show you in a little bit how many survey control you need as you're going down the project. So, for example, every 5th scan position, put a survey control out there. And if you can do in a project where you can close the loop, always close the loop on your last scan position using the same survey control, right? Distance between each scan position is relative, right? Um, and is really relative to the objects that you're scanning. So if you're doing a residential neighborhood where you're scanning on the sidewalk and the house is 20 feet away from you, you want to move it 20 feet because that's the objects that you're trying to scan. Now, if you have power lines that 50 feet away or behind the house, or even 100 feet away behind the house, it'll still get that. It'll still get that. But the message here is that you want to move accordingly to where the object is. The distance between the each scan position should be relative to the objects that you're trying to scan. So whether it's the power pole or the house, you want to move it the next position um, to that distance. Now, there's also different platforms, right? So this is talking about a tripod. And since this scanner is so fast, we're talking about what, 45 seconds for a full scan, and then to also to take the images too as well, which is an amazing um, accomplishment for us to be able to take images at the same time, because then you're now reducing the amount of time it takes to take images, right? So in the past, and with a lot of our competitors, that we'll scan and then we'll pause and then we'll take images. Well, that's going to take a lot of time. Now the images are taken at the same time. It's okay to just move roughly, 10 meters, 20 meters in a short distance. But there are also different platforms out there too as well. So there's a lot of our customers that have vehicle-mounted platforms, which is great for a lot of outdoor projects, right? You can even mount them on ATVs, and we'll do another webinars on platforms, or listen to one of my podcasts on platforms. There's a lot of platforms out there for terrestrial laser scanning. Heck, I had a customer that said that to put a scanner on the ground, and I mean, in principle, that's still a platform, right? Just putting it around on the ground. So there's a lot of platforms out there. So of course, the higher you get the scanner, the better angle of incidence that you'll have on horizontal surfaces. Vertical surfaces will get the range and will get the accuracy of the precision of the point, um, uh, regardless of the range. But on ground shots, if you're on a tripod, you're limited, right? Your diameter of returns, good returns, are limited because of the shallow returns. Now, if you have it on a vehicle where you have it up 10 to 15 or even 20 feet up in the air, now your horizontal surfaces can get much wider, and then therefore you can move at a larger distance between each scan position. So be mindful that we need the overlap, right? So the overlap is key, basically. Is what we're trying to say here. Especially working in bad GNSS conditions or projects completely without GNSS, it's best to move the scanner from one position to the next position within 20 seconds. What we mean by this is that when you're in an area with no GPS or very bad GPS, in order to make use of the automatic registration 2, um, you need some kind of positional data, and that's going to come from the IMU. So the scanner has a lot of integrated components, and one of them is an IMU. Now, it's not a really high-grade IMU where you can take it for mobile scanning, but it's good enough so that it can detect itself from one position to another when GNSS GPS is bad or is none. But there's a best practice you want to do for this, right? So from one position to the next, you want to do it within 20 to 30 seconds. I know it says 20 here, but it's 20 to 30 seconds. Uh, why is because IMU, inertial measurement units, when you pause, what happens is that you drift, right? So IMU needs to be moving the entire time in order to be effective. Um, so when you pause, when you take too long to move to the next position, it just causes a drift, right? So you want to be able to move within 20 seconds. Right. On step number 3, I talked about moving accordingly to where the object is. It's because of recommendation for number 5, overlap. I think overlap is king for our automatic registration. Now, our automatic registration tool does not make use of tie points, right? Now, this is not control points; these are tie points, where we need any kind of targets out there to register one positions to another, right? We analyze the data, compute the planes of voxels so that it can then find the matching plane. So we don't make use of any targets for registration. Now we make use of the targets to tie it down to server control. So I have to emphasize on overlap. The more overlap, the better, right? So you don't want to have anything less than 25 to 30% overlap. So therefore, you don't want to move your scan too far away so that you'll have enough overlap for the automatic registration to work properly. So yeah, so keep that in mind. The more overlap, the better. So you don't want to jump around and such, right? It is also a recommendation to set control every 5 to 10 scan positions. So what we talked about here is that when you want to make use of server control, you start with some server control and you want to end with some server control. And depending on how large the project is, whether it's linear or it's loops back around or indoor outdoor, you want to place server control accordingly, right? So you want to keep the mindset of traditional surveying. You want everything to not be biased or lean or tilt. Uh, you want to have a symmetrical distribution, a good distribution of targets throughout the entire project. Um, Maybe another webinar I can do is best practice to plan a project, right? So I'll have some scenarios where we go indoor, outdoor, linear projects, large projects, open field projects. I could do a map on how I would particularly set up these control point versus scan positions, right? Like kind of like planning project. But yes, it is recommended to use not only at the end and the beginning, beginning and the end, but also in between too as well. And it's all up to the user to define these control points and where to put them. Reflectors should be used to put only on surfaces. So we offer standard. I think we offer the flat targets versus cylindrical targets, right? So we have two types of targets that we use. Well, three actually. A prism, but make sure if you use the prism, they have to be at a certain range, and I think it's about 150 meters or something. But it's on the scanner, so if you want to select your prism, even on the software, it'll tell you the minimum distance. Otherwise, if the scanner hits that prism, it's going to shut off at that point, like you're blinking, where you look at the sun and you're blinking. So the scanner blinks or shuts off, and you're just going to get a no return on that one line, where because the return reflectance is too strong for the receiver of the scanner, so it shuts off. So if you're going to use prism, make sure you're using it at a very long range. But the flat targets, if you're going to use those, make sure you put it on a flat surfaces, flat surface, and then the angle of incidence should not be greater than, less than 30 degrees, right? So you want to have good angle of incidence using flat targets. But the cylindrical targets, we like them as well. When we do offer as a standard target for us, is that you can see them 360 degrees, great for road work. Use of RTK corrections and GNSS is recommended, but not mandatory. Yeah, so I always use GPS, whether you're getting correction from a VRS network or from a base station, or no correction at all. Our systems come with standard GPS, so always make use of GPS when it's available. And if the scanner have to be rebooted, so a lot of projects are large, or you're taking a break throughout the day, and it's okay. You don't have to be worried that, hey, I didn't finish the whole project in one day. But if you do have to either reboot to change out the battery, or to take a lunch break, or the project consists of 5 days, you want to make sure you start at where you left off, right, as close as possible, if not right on the same spot where you left off. That way the registration will continue to pick up where it is with a sufficient overlap so that the next position after that will also tie in very well too as well. So, don't just jump over the place. If you have to start where you left off, make sure you start as close as possible to the last position, which in most time it shouldn't be a problem anyways. Even on a vehicle mounted system, make sure you start where you left off too as well. Um, and if scanning leads to a dead end, the operator should return to a central already scanned location and continue from there. So at the beginning, we do recommend for you to continue the next position one after another and not jump back and forth. But I also indicated that it is okay. And there's going to be a lot of scenario where you're at a dead end, or you're doing a residential neighborhood where there's a cul-de-sac and you have nowhere else to go but make sure you want to start where you already have scan, and start with as much overlap as possible, right? So like I said, overlap is king. And then, of course, scanning outdoors and indoors of a building. This is very, very possible, and it's very achievable if it's done right. So we always recommend to first scan outside of the building, close the loop from outside, and then continue to go inside, and then back outside for one or two more positions, right? So by starting outside, it allows us to establish GPS positional data, and then once we go inside, we use that 20 or 30-second movement um, that we can make use of the IMU once we go inside too as well. Cool. So those are just some best practices recommendation, the key to success, right? So and our registration is very robust. That if you've never seen this before, and if your scanner is already registering properly, you're doing the right thing. Okay. All right. So the first, the three main parts into this webinar is Geosys Manager, automatic registration, and MSA2, which stands for multi-station adjustment, right? The Geosys Manager is should be defined based on the project. So define the coordinate system inside the project. Um, the new release of RISCAN Pro 2.9, the Geosys Manager is copied from the main folder into each project folder. Okay, so if you open up the project folder, there's a subfolder there called GSM, Geosys Manager. That's where the coordinate system database it's stored at. The uh, .dxfx file is stored. So you want to, so anytime you make an adjustment, because if you're working in a lot of different places, what happens is that you're going to have a lot of different Geosys Manager file. So that file contains the file GSFX and also the geode model file too as well. And you can change it by just right-clicking on the project name, attributes, and then click on the coordinate reference system tab, right? So there's a couple areas here that needs to be defined properly, and the output. So if you look under output, you'll see here this is a sample project. Then when I have, if time permits, we'll look at the data that I'm showing you here. That I'm using. I'll look at the data in RISCAN Pro if I have time. Um, we'll go over this in like a live demonstration, right? But here, just taking a detailed look at the Geosys Manager file, you can see, start from the top down. And this Geosys Manager file is very sensitive. So if you have something wrong or a mistake, you'll have an error, and the automatic registration workflow won't work properly. So yeah, just from the top down, if you know your EPSG code, you can just put it there and search it, and it'll populate the information for you. But here in an example project where we're in a projection coordinate system, geode datum is NAT83, map projection is Tennessee, and geode model is 03. There's also other ones you can use too as well. But here is where you need to define whether you want to work in US feet or meters or metrics, right? So when you later on you export, you just pick that file, and then the units will be tag along with it. Engineering transformation. Like I said, we can't go too deep into Geosys Manager today, but we will in the very near future. We're going to have a webinar on just Geosys Manager for TLS, or even as a whole for all RIEGL platform. But I think it'd be a good idea to hold a specific Geosys Manager webinar, so we can really get into the details of it too as well. But you do need this if you want to make use of your server control, or you can do completely localized and not use any Geosys Manager information, but then it'll just be an arbitrary point cloud. Um, okay, so again, the Geosys is defined inside the project. You can simply change it by right-clicking on the project name, selecting the coordinate system tab, and then selecting your export target coordinate reference system. And also, I didn't highlight it, but you also need to where you says import, you also need to select the same file too as well, because in the multi-session adjustment 2, step number 2, importing the survey control, you also need to select your coordinate reference system. All right. Automatic registration. So automatic registration uses the following sensors. And these are all on board, and these are hidden behind the scenes, so you don't have to go find it and such. GNSS position, the internal GPS, RTK is optional. Accelerometer is the roll pitch, and the digital compass, which give you the heading, right? So all these internal sensors, internal information, will allows you to set up the scanner without leveling it. So I don't know if a lot of people, you guys out there, we have a large crowd today. So you don't have to level the scanner, right? You have to put it in within a certain degrees. I think our specification is like 10 degrees, I believe, something like that. But as long as you have it, upright, this information is very useful. And then the IMU, which gives you the orientation, roll pitch, y'all. All this information is stored in each scan position. Okay, so each scan position has a file that has all this information in it, because each scan position obviously is completely different as far as its position and orientation. Okay. So one of the new attributes that that RIEGL has made use of, besides the planes, is the voxels, right? So, and I also want to let you guys know is that AR2 automatic registration make use of voxels versus MSA2. MSA2 does not make use of the voxels. All right, the voxels are very powerful for us. Is our new methodology to combine and define and bring all these scan positions together. So voxels can be imagined as a cube with a certain physical size in meters, right? So you can define the cube, you can customize these voxels based on your scene. If you don't get good results, you can make customized voxels. The physical size of the voxels is just determined by the voxel size parameters. So you can set whatever size you want. And we have recommendation on different scenario. When I say scenario, I mean whether you do an indoor scan or outdoor scan. Like, for example, choose a small voxel size, 10 centimeter for indoor projects. And then for a large scale projects like an open pit, you want to use a large voxel size, which is here 4 meters. Voxel count is the parameter that determines how many voxels that are used in the X, Y, and Z directions during the registration process. So small values such as 125 will shorten the calculation time, and it may cause the scan position to fail, right? So you don't want to use too small. Whereas large voxel size such as 4,096 will increase the calculation time, but it's required for such large scene. So you want to choose accordingly based on our recommendation for sure. And detect from scan position. So this is cool. I recently did a project where it's completely open. I think it's a mine query, and there's a lot of there's no vertical surfaces. Everything is just completely flat, open pit. Um, so I had to detect. So as it's registering and it failed, um, and the manual assistant, I wasn't able to help it. So I was able to right click on, select the scan data, and then use the detect from scan position so that it made the voxel based on that scan, that one scan, so that it can find the common surfaces for other to match the other scans. So here's just some scenarios and some voxel sizes that you know um, we've made use for you guys. So for indoor small, you want to use it, like I said earlier, the small voxel size, and outdoor larger and larger and larger and such not. Um, Outdoor urban, so this could be very dense forestry or very not so dense forestry. Um, but these tools work amazingly well in in forest condition, and non-urban environment. I'm quite blown away how well this registration tool works. But as long as you follow all the recommendation that I had said at the beginning of my presentation, is that you need to overlap, you need to move the scan quick, you need to move it short according to the object of the distance. And if you do all that right, if you select the right scenario, you're going to be very successful, and that's the message. Um, okay. All right, so moving on to automatic registration 2. So I didn't show you guys on how to bring the data in, right? So this is a project where I have X amount of scan positions. Um, this automatic registration tool is great. So what is great about it is that it gives you a lot of flexibility. And what I mean by flexibility is that you don't have to register the entire project. And not only that you don't have to register the entire project, you can continue registering days after, right? So if you have a project where you have to spend 3 days scanning, you have 1,000 scan position or more. You can register each day at a time, and then just keep on adding to it, right? So don't select the positions that you don't want to register, and just select only the positions that you want to register. Um, and you just select the position that you want to register. You just click on that little um, map grid icon, or hit F3 for shortcut, and then select automatic registration 2. Now, as you can see from here, we also have other methods to register uh, the data, right? So we haven't really taken away any traditional stuff. We've just introduced the automatic registration tool. So we have the backsite, we have the traverse, free station where you just throwing targets out there and you just tying it down, resection rather, and then 1 point reference, 2 point reference. Um, if you want to see any of those ones, let me know, and then we'll show you how to do it. And then once you select automatic registration, you'll get a display box or a prompt, and it allows you just for a couple simple questions, right? So, what scenario are you doing? Um, as you can see here is outdoor urban. This is the project that I will show you later, which has a smaller voxel size versus if you were to go outdoor non-urban, it'll have a much larger voxel size. Um, and then manual assistance, you want it on failure, so that if it can't find a solution based on the matching voxels of the planes, you can rotate it. If you lost positions at that one scan position, or it was so bad that you can rotate it and manually move it to where it needs to be, um, and then you can ask you if you're carrying it on a manual tripod or mounted on a vehicle. Um, Please select the right one. You don't want to, if you're on a tripod, you don't want to select mounted on a vehicle, right? So the reason why we have the two is because when you're mounted on a vehicle, um, it assumes that the vehicle will project a large magnetic error on the digital compass, right? So on a tripod, there's no metal around it, but on a vehicle, it assumes that it's it's metal, so the projected error on the digital compass is much higher as you were, so it accommodates that based on the selection right here. So select the appropriate platform that you're using, whether it's a tripod or a mounted vehicle. Um, and then once you select your scene, do the drop down, you want to select it accordingly. And we'll just take a look at these scenes really quick. So automatic selection, the project scenario will be divided automatically from the main scan position of the first position, right? So that's just the first position. And what's great about this, earlier I had said the tool is very flexible, is that if you were doing a project where you're, let's say, indoor scanning, so you'd use indoor small, and if you had to go outdoor, you can pause it. You can pause the registration or even cancel it, and then select the one for outdoor. You can then just continue with outdoor with a different scene scenario. So that's the flexibility of this. But I always tell customers, of course, always choose the um, the appropriate scenario. Therefore, it maximizes the use of voxels intelligently and properly. And then custom settings. I've tried this just to play around, but unless you have all these scenarios that do not work, yeah, maybe get into custom settings where you can just go into the help content and then get more information on the custom settings. But it's not really that um, hard to do or to define. But yeah, always it's so it's easier just to use one of these predetermined scenarios, right? So and then you hit start. So the time it takes to register each camp position is approximately around 20 seconds or so. So here we have a project here. I have roughly so this is the results that you get afterwards, right? Um, so this project you're looking at has approximately almost 25 scan position. It took me no more than 10 minutes to do automatically, I think. But after it's done, there's a lot of uh, information stored as far as looking at the overall, the initial um, voxels that's generated. And this tool is very useful right here. So after it's done, you can look at the overview and how well it is aligned together. So if you look under the overview files, you just drag it in, and then your view type under attributes, just change it to standard deviation, and then from the deviation, you just want to select your gradient from minimum to max. So always set minimum to 0, and then your max could be whatever scale you want. Here I have it in US feet at 300s, right? So 300s is a good benchmark to look at these errors. Gradient cycle, always 1 when looking at it in the standard deviation. And then your color gradient, so that's up to you. So if you do the drop down, there's tons of different color gradient that you can choose from. But I just use a simple blue to red. And you can see here is that everything over 300s is fuchsia, right? So it's an easy color to recognize for me. So you can see a lot of fuchsia, but you also looking at the vegetation, okay? And hopefully I get to show you this project if I have time, is that all this point cloud was done, this project was done in the rain. We scanned it when it was rain and snow was coming down, so there's a bunch of noise in this data from the rain and the noise. But nevertheless, the surfaces that you want to concentrate on are the roads and the buildings. But you can see here, the registration here is really good. This is just the initial overall registration before MSA2. This is just right after AR2, automatic registration 2. You can see here the road surfaces. There's nothing is in the fuchsia. Everything in the fuchsia colored is vegetation or dark surfaces or reflection. Um, so it does a very good job at uh, with the automatic registration already. Okay. And then don't forget what I just showed you. It can also be done completely on the scanner. So those of you that have a VZ400i or VZ2000i, particularly with the new onboard processor, the high-speed onboard processor, you can really skip out AR2, which is automatic registry, and you can do that on board. So here is an example of how you can look at the interface where we're at scan position 101, but above that, there's already been 100 scan position registered. Not only this is one of the customized apps, there's many more that you can customize to as well, and we'll get that into another webinar. Um, but yeah, the VZ400i is quite impressive as far as uh, the user interface, the capability, and the customization that you can really make the scanner your own, right? And really all this stuff is to increase productivity. The scan speed, the images taken at the same time, the automatic registration, all of this really is to increase productivity. I've been in the industry for 12 years with RIEGL, and the advancements that I've seen throughout the entire industry, particularly with the RIEGL, it's night and day. It's beautiful. Our scanner used to take 10 minutes to do a panorama 40, which is 6.5 centimeters at 100 meter. Now it does that in 45 seconds. So, and with that, you can really talk about productivity now versus, the technology, right? So the technology has been proven. I think it's been accepted. It's been used. It's been tested. It's been brought through the ringer by all departments: engineering, surveying, departments, DOTs to USGS. All that stuff has been tested, and now we're really worried about productivity and ease of use. We don't have to worry about going out scanning uh, all day and then taking, uh, you know, 3 days to process the data. We want to make that a little bit the better ratio, right? So by utilizing such capability of the 400i, like onboard registration, you can really cut out a lot of your time and to really make a streamlined workflow and to increase productivity. Okay. All right. So once AR2 is done, we want to go ahead and get into MSA2. MSA2 stands for Multi-Station Adjustment 2. Those existing customers that have used MSA, it's pretty much the same principle, but it's automatic. MSA2 is meant to be executed after automatic registration 2 and to further optimize the mutual registration and georeferencing of all registered scan position in a project by adjusting the SOP matrix. SOP stands for scanner's own positions, right? So every single scan position has its own SOP. So what this tool does is that it then adjusts each scan position based on the matching planes, based on the server control, to then give you the best results. Um, if there are registered scan positions that are not taking into account for MSA, then they will lose their registration state. Frozen scan positions will be taken into account for MSA2, but will stay fixed. Um, this is cool too as well. So this is in a project scenario where you did a couple resections on a couple scans, and you tie it down to survey control, and you don't, and those are your base points. You don't want those things to move. You can freeze them and still make use of the multi-session tool where you have other scans tied to it, right? So if you strategically um, um, set your scan position um, around the project and you control those ones, um, everything else you scan in the middle can be fixed to it. So instead of tying down to 6 survey control out in the project, or 10 or 20, whatever the case is, you can make use of the plane surfaces. So in a sense, those all are also considered control, right? Because you're using it as a base, and then you're tying different scan positions to it. So you're not only using much more control from the point cloud versus just the sum. So that's just another scenario. MSA2 alignment process does not use this voxel at all. So earlier I had mentioned that don't get confused with the voxels, right? So the voxels are not used everywhere. It's only made use in the automatic registration too. So MSA2 does not make use of the voxel. However, the voxel creates a visual quality inspection. Um, yeah, so that's great because the voxels not only is used in AR2, you can also use this to analyze. And recently, we released a voxel tool to compare surfaces. This is great for the mining industry for volumetric comparison, quantity to quantify, and then also for slope stability monitoring. Right, so you can use this voxel tool to monitor slope failures. Sorry, the voxels to monitor the slope failures. Yeah. MSA2 will consider sensors measurements such as roll pitch yaw, and then also moving down, MSA takes GNSS measurement into account to adjust absolute position. So yeah, that's the powerfulness of MSA2. So MSA2 not only does the plane-to-plane surface adjustment, it also does adjustment down to the best GPS positions, right? So if you had 10 scan positions, and if and they all had RTK values on them, which is, let's just say 2 centimeter or better. And GPS, again, it's all relative anyways. Um, but if you had a position where you lost the GPS signal, or you're next to a building where you're getting a lot of bouncing off the vertical surfaces, buildings, it would take that into account. So it could see it as an outlier, and it would make the best adjustments for that outlier. And then MSA2 can also take in coordinates control point. I think everybody uses control point if you're not using RTK. So um, that's the flexibility of MSA2, right? You can control your project with just GPS, or you control it without GPS. You control it with just survey control. Um, okay. All right. Moving on. So that's the principle. Let's get into it, right? So um, after you do the automatic registration two, your project will look just like this, right? You don't want to have nothing on the screen. Just go ahead and then click on registration, and then select motorization adjustment 2, which is also F4. Once you select that, you're going to get a dialog box, and it looks completely empty. Now, those of you that are not aware is that when you import, download, and convert the data, the raw data from the scanner, um, it'll ask you for two options. One is to define your geosys manager, and the other one is to define your type of targets, right? If you've already defined your type of targets, you can almost skip step number 1, but I'm assuming you don't, so we're going to go look at step number 1, which is defining your targets. Yeah? And then step number 2 is import control, and then you want to find the links. I typically skip step number 4. I've played around with it quite a bit, but it's just a visual inspection tool. It's not, doesn't really, it gives you any flexibility to make adjustments. It just gives you a visual, right? So these are the visual from the voxels, right? You can see, I showed you earlier about the point cloud setting a viewing it in a standard deviation. This is the same thing. It allows you to inspect, and it also allows you to see which position is tied to a server control. So I usually skip step number 4. In fact, I skipped it in here too as well. It doesn't really have that big of an effect. And then step number 5, of course, is the most important one. Okay, so we'll take a tour through the MSA2. So generate tie points, import server control, and that can be done from the Glocks or from the LLC. LLC stands for Localized Coordinate System. This is for a customized one. This is for if you want to set your own boundary where you have a 10,000, 10,000, 5,000 elevation, right? Um, but on a calibrated site, or rather an engineering site, you still want to use global coordinate system, but you have to go through one step, the engineering transformation, in order to make use of that. And then you want to find corresponding point, expect, execute. This is very important. If you do not make use of survey control, please skip straight to step number 5. Okay? So if you're doing a project where you have a differential GPS on top of the scanner, and if you don't have any server control, You can just go straight to step number 5. This project could be done for like bridge clearance, right? So you don't need to set server control out for bridges, um, unless you're using the data for something else. But if you're just doing, a state job where where the state wants to know all the clearance of all their bridges, um, you don't need server control. All you need is, whether it's RTK or GPS. Then you just skip to straight number 5. You just skip. That's the flexibility of this. So that's a big push. You can always make use. So the message here is that you can always make use of MSA2, whether you're using server control or you're not using server control. Step number 1, generate the tie points. So there's a little gearbox at the top. You'll see. You click on it. It allows you to define what type of target you're using. Now, you're not dedicated to one type of target. Okay, you can use a combination of reflectors, whether it's a flat, cylindrical, or a prism, or you can even define your own. You can define your own inside the software, or you can define your own on the scanner inside the workflow. Um, so you can define your own target, but the message is that you can use a combination of both. Once you define your target, you just hit generate tie point, and then you're going to get then your list is going to be populated with all the tie points. Now, I want to take a minute to go over this. There's 2 sets of values that I want to explain here. One, the vertical oval is the number of targets that it saw. Now, you don't add all those up and say, hey, those are how many targets out there. No. What that means is that, for example, TP underscore 013, that means that target was fine scan or seen from 3 different positions. Okay? 3 different positions, meaning that you put that target up there and then you saw it from 3 different positions. Now, you don't have to see it from 3 different positions, but if you do, you're going to get a deltas. You're going to get deltas for them, right? So what that means is that the difference between wherever you move 3 scan. So in this scenario where TP underscore 01 has a delta X of 0.41, delta Y of 0.03, and delta Z of 0.003. So what this means is that target moved. That target moved. So in my opinion, in my recommendation, you may want to do a little bit of investigation on that target. Okay. So, and you can see it moved in the X, Y, and Z direction, but not in the vertical direction. So it didn't go up or down. It just moved, left or right in the positive or negative direction. Okay. You can even uncheck that. So if you have, good amount of server control out there, you might just want to uncheck it and then move on to the find corresponding point. But this can also limit you from finding corresponding points too as well. So if you look at the rest where TP stands for tie point, by the way, and then OP stands for observation point, right? When you have 2 or more, it becomes a tie point so that you can reference it from a different scan position. If you have 1 or more, it's an observation point. So that means you can only use to tie down to server control. Now, you can't use it to tie down from one position to another. You can only use it to tie down server control. You can see TP01 to TP02 to TP05, the deltas on it, it's nearly perfect. You're talking about millimeters difference, right? Which is pretty much a scanner error anyways. So this is a very good visual and chart for you to see which server control is potentially busted, or which scan position that saw the control that the tripod might have moved and such. So it's a very good observation. Step number 2. So once you import your tie pointing, you just click on step number 2, and it takes you to this list, right? So this project is defined using State Plane, Tennessee. So I've already defined that in my Geosys manager, and then I just select my CSV file. Add the rod height to the control file. There's a lot of questions out that we've received that, hey, where do I add the rod height to? Add it to the server control file. RIEGL Pro has it's been around since the Z series of scanners from RIEGL. Um, so what happened is that RIEGL Pro is tailored to the old generation of scanners workflow, and also continue on to the new generation scanner workflow. So we don't have to make 10 different RIEGL Pro. We just keep on adding different tools. But of course, um, add the rod height to the server control file, please. Okay, and you want to make a copy. Make one copy. Like I said, this one has targets underscore height, and I have another one without the height from the original file. So later on, I can drag it in and I can show you where it is on the ground. Okay. So once you find your CSV file, just follow the import steps and just hit OK and move on. And then the third step is find corresponding points. Rather here is find links, right? You want to match the distance tolerance. I usually just keep it as default 10 centimeter or 3/10 of a foot. Number of corresponding points. Um, 3 is the minimum, so you can't go less than 3. But if you have 25 out there, you don't want to put 25. Okay. Um, don't worry, you will have an option to include them if they don't find them. 3 points makes the plane kind of deal here, so that minimum's 3. For example, if I have 10 out there, I'll put 6, or I'll put 8, right? And I'm not going to put 10 because it may not find a solution because the automatic registration 2 may not be perfect. So you can see if your initial registration is not perfect, what happens is that you're going to limit yourself from finding all the points. And we don't expect the AR2 to be um, completely perfect the first time anyways. That's why we give an option to use motion station adjustment 2. But so don't put the amount of points that you have out there. This one I put 4. I think I have 5 or 6 out there, but I have 4 here. And then you hit start, and then you get a solution. So number of corresponding points is 5, and the standard deviation value for those 5 points that I found is just around 2 centimeter, right? Just under 2 centimeter. And then you want to make sure you hit accept solution and establish the link. So it's very important that you do this. Okay. And then now you can see my dialog box has populated with a lot of information. Particularly, these are all just tie points and the targets out in the field. So from the box to the top left, those are your survey. So those are your tie points, rather your fine scan, right? So the scanner zooms and focuses on the target and gives it a much higher resolution scan so they can find the center and apply the offset if you're using a cylindrical target. And then on the right-hand side is the control point. So these are the survey control point that you got from the surveyor. Okay. And then on the bottom is the link. Now, there's going to be time where on this project I have 5 survey controls, so there's only 5 links here. But there's going to be time where you don't find all the links. Well, that box I just highlighted in a circle, that'll be green. Okay, that will tell you that hey, I didn't find another control. Do you want me to force the other one in there? Okay, or make use of it rather. And of course, you want to go ahead and hit yes. But it'll be green if there's any available that it didn't find. And of course, you want to executing and applying the block adjustment before MSA2 ensures all scan positions are at a good initial starting position before running step number 5, which is executing MSA2, which will make the comparison of the initial voxels and the final voxels easier, right? So you want to execute it, and then you want to apply the calculation results. You can see here, once you execute it, you're going to get your block transformation, which gives you the XYZ and the rotation and translation, right? So you can see from the translation of roll, pitch, and yaw, our project was pretty level to begin with. Okay, so that's from the internal sensor. The block, the translation, which is the X, Y, and Z, is not much far from where, so it didn't move that much. Well, it made sense because on this project I didn't use RTK, I just used the internal GPS, which is its L1 signal. So the accuracy of my project was, anywhere from 2 to 5 millimeter. No, sorry, 2 to 5 meters. So it wasn't big transformation here. And then you want to go ahead and hit yes and just follow the workflow. Okay. All right. So, and then now step 5. This is the final step. We're going to go ahead and explain. I think I am running out of time. I think my colleague's supposed to let me know. But yeah. So once you finish step number 3, you can visualize the data with step number 4. But then again, I said earlier, it's not really much useful as far as tool-wise. It's just a good visualization and inspection, tool-wise, utilize control and tie points, right? So you have established links between the control points and the observation points in the previous steps. Then you can include or exclude these points in MSA2 by checking, and I don't know why you definitely want to check it if you're using server control. If not, then no. But on utilizing GNSS, this is important. So if you're out there and if you're having some trouble with this, it's because you're probably not selecting yes or no properly, right? So here's the message. If you are using survey control and you have to tie your data down to server control, please select no. Ignore the GNSS. If you are not using survey control, and if you're using RTK particularly, definitely hit yes. Okay, that's a very important message. So if you are using survey control, hit no, select no. If you are not using survey control and want to utilize the GNSS, especially with RTK, then hit yes. Or even with just the internal GPS, hit yes. Right? Do not utilize the GNSS if you are using server control, because it takes that into account. So typically, server control are much tighter, better accuracy than just GPS, right? So earlier, when I had displayed the principle of MSA2, GPS is being accountable for during this step number 5 process. Voxel size. So select the appropriate scenario. We had talked about the voxel size earlier. Just select the right scenario, and you'll see the voxel size right underneath it once you change it. Gap closure. There's always been questions about gap closure too as well. So if you do have a scene from different scan position, you can find this information by simply doing a cross section, right? So if you're going to use a project where you're using closing the loop, bring in the first scan position, bring in the last scan position, do a cross section, turn it sideways, put on the chart. You can find out the gap closure by simply just doing a couple cross sections. Or if you're doing a corridor project, put all the line together, do a slice down the road, turn sideways, turn on your graph, and you can see the gap closure. So you want to select the right gap closure according to the separation of the scans. Yeah. And then matching methods. This is important too as well. Planes to planes is the default and recommended use for most urban and non-urban environments in the MSA2 modes. But more importantly, don't use points to planes if you're in those environments, right? Only use points to plane when you're in an area where forestry, open pit application, where you're doing a topo of a rural area with no vertical trees or anything. Sorry, in a rural environment, where you're doing a land survey before the building goes up or the roads get put down. Um, so please select plains to plains in most urban, if not all urban environments. Okay, so only use points to points when you're in a very rural area. That's the message. All right, so we're getting towards the end. And then adjustment effort, and I'll go down and label and list all the selections within the adjustment effort. You don't always want to pick extreme, okay? It's not necessary, and it's not necessary to pick low all the time or high, right? I always start with standard. So what's going to happen is that if you have 100 scan position or 1,000, which is very realistic these days because how fast the scanner is, you can really rack up 100 scan position in no time. Um, you pick a stream on a project where it has a 500 scan position, it's going to take you a very long time. And you got to have the computer to do it. You got to have memory and RAM in there to do it too as well. So select your adjustment effort accordingly. And I believe this presentation is going to be available for the public. I'll have to confirm that with my colleague, but I believe it is. There's nothing in here that's sensitive. Um, so yeah, so depending on the selection, it would use the amount of planes um, um, based on that selection, right? So low, standard, higher, extreme. The block adjustment is a little bit different. The block adjustment is a special adjustment effort that adjusts the entire project just to the server control. This could be useful in some cases, right? So in some cases where your data is perfectly aligned up together, and you don't want to break it apart, this block adjustment will then do a resection down to the server control only. Okay. Now I'm not saying this works on everything, but I know on a project where I'm just doing, for example, on I don't know, Alta survey, where I have everything together perfectly because there's a lot of good surfaces out there, and the automatic registration work brilliantly. I can just do a block adjustment where it's just down to the server control. Okay. And then you hit start. That's it. And then you just watch it run. You'll see the 3 bars right below the start button where it says overall, phase, and pass. Those that get populated with percentage. It's a percentage bar. And then once it turns green, you're done. That's it. That's the whole workflow of AR2 and MSA2. So now I think we have a little bit time left, so that I can then. Oh, thank you. And then for information, please, that's my contact right here. Feel free to give me an email and send me email on some topics that you'd like me to discuss, even some broadcast topics that you'd like me to speak about too as well. And then we'll go from there. So now, if I can, I will take a look at the project that here. Okay. So this is the project that that's in my presentation. Um, the only thing I've done is ran AR2, right? So, and I only did one thing, was just ran the automatic registration too. Okay. Here I can display it in standard deviation. Where are you? Oh, sorry. No, that's fine. Okay. So I can view it here. Make sure I select the right coordinate system. So there we go. And I'm also going to do put together a webinar where I have some external different data, right? So here we have a RIEGL VUX, mini VUX DL. So this project I have also has the so what I'm going to do here is that I'm going to do a cross section. Now this is the project that I did in snow and rain. Well, it's wet snow, I guess. So you're going to see a lot of noise. I haven't done any filter yet, and this will be a series of okay. Now you can see the points displaying each color very tight. And this is looking at it from the first scan position and loop around to the last scan position. You can see it's very, very tight. Okay. So this is just right after running MSA, AR2. So this is before MSA2. And then I'm just going to bring in the server control. So here, split this window in half. So these one don't have the rod height added to it. Bring them right in. And these one do have the rod height added to it. Okay. Now, what I want to show you here is that, see how off it is, right? Okay. So now I'm going to go ahead and run motion sensation adjustment 2. There we go. So the first step is to generate the tie points, which out here I'm only using the 10 centimeter target, 100 millimeters, same thing. Okay. Generate. Oops, sorry. Generate. Okay. Then here, I'm going to import my server control with height. Hit OK. Before I do this, I like to, no, that's fine. Okay, import server control. So make sure you select the right coordinate system. Make sure easting and northing is proper. There we go. Then now step 3, link them together. Yep, that's fine. Hit start. Perfect. It found 4 at just over 5 centimeter. No problem. Establish the link. Hit OK. So you see how there, establish only 4 links, but I have 5. So it gives me an option to add the not selected link. There we go. And execute. And then apply. Yes. Okay. I don't know if you noticed, but my point cloud shifted. Okay. We can minimize that. Now you can see, without even running the step number 5, I'm right on it. The bottom one is it's the file without the survey height. So that's from the surveyor. And then this one's up here is because I had to add the height of the tripod that's holding up the target. Yeah, that's beautiful. Yep. And then now I'll just run step number 5. That's it. So in this case, I would hit no, outdoor urban. Gap closure, I thought it was excellent, so I'm going to use the smallest value. This one I'm using planes to plane because I'm in an urban environment. Standard adjustment is adjustment effort is standard. Report. Oh, I didn't go over this earlier, and I'm sorry. And I didn't think I had time, and it wasn't really important for me to put it into a PowerPoint. Standard report level. We'll go over that another day. But you can choose what kind of report level you want, right? So if you have a full report, I recommend that. Is because it gives you how many planes they found, the matching planes, the accuracy, the standard deviation of the planes, so how well everything sits together, and then also down to the survey control, GPS information. All the information from the scan data from each scan position is stored into the report control, and we'll do that at another PowerPoint. I just didn't think I have time today. Of course, global position is always the coordinate system you're working in. Operator's name is Nguyen. Show report, I don't ever use that. That's stored under report right here. And once I run it, and then show report, and then the initial voxels, I don't display those either, right? So it's all user defined here. It's customized here. I don't. This is none of these settings I'm showing you right now will affect the automatic registration. So you saw me. So to summarize it, we went over the automatic registration workflow. We talked about the importance of Joseph's Manager and where it needs to be if you're using it. We talked about some of the options that in AR2, which is automatic registration, selecting the different scenes and also explaining a little bit what the voxels mean, and then customizing the voxel sizes if necessary. If not, just select the proper scenario, and it then determines the voxel size based on the first scan position. And then from there, we check it, right? So we can display the data after the registration and see it in a standard deviation view where you set your limits to 0 and then X meaning that earlier I set it to 3 centimeter, 300ths of a foot. And then from there, once we accept the registration from AR2, we moved on to MSA Motion Section Adjustment 2, in which I kind of just went over here, where we went over the 5 steps, and then we saw me bringing the server control where it was, and then where it is after the fine length, right, which is really cool. Yep, and then now I'm doing the last step, which is start adjustment. Now, you can run this multiple times, okay? So, all right, guys, I think that's all the time I have. Thank you very much for your attention. Thank you very much for your time. Good luck out there. If you have any questions, please send me an email, contact me. If you want more information, feel free to contact me. And let me put up my contact for just a little bit longer so that those of you who don't have it. Okay. Well, everybody, thank you. Have a nice day. Stay safe out there, and we'll talk to you soon. Bye. Oh, I'm sorry. So the question and answer. Okay. I forgot about that. Let's see. I'm looking at some questions now. So sorry if I missed that. Let's see. I'm looking at some questions right now. Okay, they keep on coming in. What I'm just going from the top down. What could be the workflow for tunneling projects with different ramification that is not possible to close the loop? Okay, so tunnel projects. So on projects where it's linear, like a tunnel itself, where you can't close the loop, it's okay. You want to establish control at the beginning. You want to establish control at the end. And then in my recommendation, have 1 or 2 control. And when you start your control, I recommend to do 3 at the beginning and 3 at the end, right? So 3 points makes a plane, right? Um, you can use two definitely, but I would definitely avoid one. I would definitely use two or more from the beginning and end. And in the middle, every, let's say, six scan position, make sure you hit a survey control. Here's a tip: when you hit a survey control, hit it from two position. I find that to be the best workflow. Hit it from two position, right? So you hit it from the first position, you hit it from the second position. Okay. But yeah, it's definitely possible. You have to use server control. Hit it couple at the front, couple at the end, and then of course every six scan position, every eight scan position, put one or two out there and hit it from two position. How well does the auto registration work within RIEGL Pro for older scanners comparable to new scanners? Okay, so we got a question to ask about. Can they make use of the older generation scanners? For example, a VZ400i. The VZ400, the VZ 1000, the VZ 2000, and the VZ 4000 and 6000. You can make use of it, but you have to have GPS. You have to use GPS in order to make use of automatic registration too. You have to make use of GPS. You can even use external GPS. So if you were using a system that did not have any GPS, you can use external GPS. You're going to have to contact me to get more information on how to make use of external GPS. Okay. Can GPS data from external handheld kit like Arrow Gold be tied? Yeah. So, question about using non-traditional surveying GPS, right? So, and I've seen this from a lot of universities. So, a university, they don't have the budget to buy these high-end differential GPS. They use like a handheld. Well, you can make use of it, but it's going to be a little bit more work. And what I mean about a little bit more work is you lose the accuracy of the position of the GPS to where the scanner is, right? Because you don't have it fixed mounted. I don't know how you guys are mounting it, but if you're just like setting your hand over it, yeah, now you're guessing where that GPS is supposed to go. So there's a tool inside RIEGL Pro where we can link external GPS to the scan position very easily. But what happens is that you're gonna, it's gonna be a much larger error as far as your position, and then also we just don't recommend to use the handheld, but you certainly can. So you know what, that seems to be a question that's coming out a lot in here. So maybe my next PowerPoint for GPS integration and make use of external GPS. Are voxels replacing the use of polylayer for scan registration? Voxels make use. I'm not exactly sure about that. Are voxels replacing the use of poly data for registers? I'm not exactly sure. So I know voxel is the new attributes that we've introduced with the latest software, RIEGL Pro 2.9, and then also to make use of the RDB 2.0 files data from the scanner. Does that mean the 400i is waterproof? The VZ400i has a very good IP rating, but it's definitely not waterproof. It's water resistance. The VZ400i has an IP64, which is dust proof and splash proof, right? So it's not waterproof. Just like you can't sink it. You can get it wet, you can't sink it. Now, I have done a lot of projects in conditions that rainy conditions. Will recording? Yes, this webinar will be available. Recording will be available. Would it be nice if you can document what you have presented today? I can see how we can document this down, but the presentation will be available. Can you also take a close look at the report? Yes, I don't have time to go over the report today, but Sandra Lawrence, if you're out there still, you can just send me an email, and then I can explain the report to you. Or that could be another webinar that I can do explaining the report. Can you please explain again about 20-second gap between each? So the 20-second gap between each scan position, that means that it should only take you 20 seconds. Like you shouldn't keep on walking for a whole minute, right? So the gap between each scan position should only be a 20-second, right? So however fast you can move within 20 seconds. Recording will be, recording will be available. What kind of computer do you need? Computer, what kind of computer do we need to run our software? Nothing robust. I have a Dell Precision, and I process all of my data, whether it's 2 scan position or 100 scan position. I process all of my Dell Precision, which has an iCore 7 8th generation Intel. I think I only have 16 gigs of RAM. But the most important is a graphic card. So Ron Bear, if you're out there, we recommend a NVIDIA graphic card. If you want a specific model, send me an email and I'll give you the specific model. But computer-wise, we don't need nothing robust. Of course, more robust the better. So ramp up on the RAM, maybe 32 gigs of RAM or 16 minimum. But NVIDIA is what you want to go with, right? Let's see other questions. Okay. What's the precisions of the accelerometer, the roll pitch and yaw? I think it's in thousandths of a degree. I don't know the exact number, but it's in the thousandths of a degree. I don't know off the top of my head. I'll have to dig through. It's on the data sheet, so if you want to visit our website, I believe that information is on the data sheet. If not, if you don't find it on there, send me an email and I'll let you know. Time points is fine scanned by the scanner. Then what is observation point? Same thing. A fine scan. So somebody wants to know what is the difference between a fine scan and an observation point. A fine scan is just a tool that we labeled a fine scan. Is that when it scans, right? It scans the scene, and if there's a target inside the scene, we can select that target, and then the tool is called fine scan, right? So we fine scan it. That means that it puts a lot of points on there based, so it sets its own rotation angle based on the distance of the target to where the scanner is. It sets its own rotation angle to put enough points in there to define the target accurately. Now, these targets could be used at near or far range, right? So I don't recommend having the target right next to the scanner, right? Have it 10 feet away, 20 feet away. Don't have the target 500 feet away. Have it within, 200 feet away at the max, or 150 feet away at the max. But if you need to, at ultra long range, use a prism. And an observation point. That's the point that it observed, and it's going to be used in the MSA2 or find a corresponding point down to your survey control. That's an observation point. So if you want to make use of the automatic onboard registration, no, it will not give you a notification, but it will have a display. It will display if your position failed or not. It will not send you a trigger or anything. Can you use disinfectant? Andrew Hunter, good question. I don't know. Yes, I would say yes. You can use a disinfectant to clean it. How can I set the scan position fixed during AR2 because this particular position was default previously adjustment, and now I can have used that position as a reference during my scan adjustment. So an automatic scan position. So in AR2, a viewer asked if they can set it fixed. Now, it all depends on if you're using a resection method or you're using a cloud to cloud. Okay, that's a good question. I know how to use it in the MSA2, but I don't know how to set it fixed in the AR2 when using just the cloud to cloud. I don't believe you can. I only think you can use a fixed frozen position in MSA2. Does MSA2 work for projects that have been partially registered with MSA1? For instance, the facade building. Does MSA2 work for projects that have been partially registered with MSA1? Okay. For instance, the facade of a building scanned with type points and using only a few scans. Well, AR2 and MSA2, it's two different tool. And also MSA1 is a different tool too as well. And what I mean by different is that once you run automatic registration, you can stop there. Your data could be good. It all relative to how well you want to accept it, right? But it could be good. In fact, you can run MSA2 as many times. Sorry, AR2 as many times as you want. So if you're running AR2, which is automatic registration 2, and if you don't like it, you can keep on running it, and it'll get better. It doesn't start from the beginning. It starts from where it left off. That being said, can you combine it with MSA1? I don't know if that's a typo or not, but for MSA1, yes, you can. You can. So once you run AR2, automatic registration 2, on the positions that you want, you can open up MSA1, lock the position that you use on AR2, and then link the other ones to it, MSA1 positions to it. Hope that makes sense. If not, send me an email and I'll explain a little bit more in detail. But yeah, your question, does MSA2 work for projects that have been partially registered with MSA1? For instance, the facade of a building scanned with type points and using only a few scans, and inside with good overlapping? Yes, you can. Okay. Okay, I think that's all the time I have left for today. I know there's another webinar coming on. So thank you guys for your attention. Thank you for one that stuck around. Very good audience. Everybody have a nice day, and then we'll talk to you later. And stay tuned for my next webinar. I'm still looking for no, my next webinar is going to be on tools, tips, and tricks. Okay, in May, and you'll see towards the end of May, you will see an invitation for it. All right, guys. Have a nice day. If I did not answer your question, you have my email. Just send me an email, and then we'll get you answered.